Okay. Okay, start. Let's continue. So, what was I saying? 17 choose 3. You got the 680. Wait, let me share screen first. Bearing. Wait a minute. Okay. Yeah, so that's 17 choose 3. So can you see the general pattern already? If I change this now into, let's say, 18 choose 4, what would this be equal to? As a fraction? I can show. Actually, is my calculator... Wait, I need to change to screen mode.
3060.
Yeah, then manually, what would the formula be?
18 times
15 times 17 times 16 times 15. How do you know I stop at 15? Because you see the number 4 at the bottom. 1, 2, 3, 4 factors at the top. Then divide by 4 factorial. Can you see that?
Yeah.
Do you understand the pattern now? How to find 18 choose R? N choose R? In general, this guy here, if the number is small, you just count 1, 2, 3, 4. But how do you generalize the pattern relating 18 and 4 with 15? Isn't this just 18 minus 4 plus 1? Yes, right? Then in general, 18 is actually N, 4 is actually R, so the formula is N minus R plus 1. 18 can be any, the 18 can be any big number, the R can be any small number. Then big number choose small number, it will always stop at N minus R plus 1, which is why the formula here gave you N minus 1 count down, dot, dot, dot means you continue counting down, you see the pattern until you hit N minus R plus 1, just like this. 18, then count down to N 17, then 16, and then finally stop at N minus R plus 1. 18 minus 4 plus 1, which is 15. Then divide by R factorial, which is 4 factorial. Okay? Can? Okay, Very good. Move on. So this is the expansion. You have to use the formula. Let me just send you this file first. Okay, it's called the MF26. You can use it. We'll be referencing to it. So now let's try and solve some questions. Let's see. So the basic examples, let's see. Question 2. Using the standard series expansions, you want to expand this e to the power of negative 2x multiplied by ln of 2 plus x in ascending powers of x up to and including a term in x cubed. So what you want to do is not to go and let fx equal to this whole thing and then you manually do it. No, they said using standard series expansion, right? So what you want to do is to treat this as one single f, treat this as another function g of x. Then you expand it. So let's look at the MF26. I'll split the screen. Then if we see the e power negative, if we look at the Maclaurin series standard expansions, you see e power x has this formula, right? Can you see that? Then you are just going to use the formula, but replacing the x with negative 2x. So let's do that, expand. So for fx, it is approximately, fx is the e power negative 2x. 1 plus, but here the x replaced with negative 2x, so negative 2x plus something square over 2 factorial. The something is negative 2x. Does it make sense so far? But let's read the question requirement. So many terms to expand. When do I stop? You need up to x cubed term. Remember from binomial theorem, you only expand up to the term that's relevant. You're going to multiply it by ln 2 plus x. You're going to expand it as well. Then you're going to multiply together the pairs of terms. You remember your binomial theorem question? You did so many, like you open up like 1 plus x squared, and then you multiply by 1 plus, then you distribute. Remember? Yes, it's the same concept. Just made a little bit more complicated with the Maclaurin series. Okay, so which term do you want? Do you want the next one, which is power 3? Yes or no? Here, x cubed over 3 factorial, this one. Would you want to use that? Can see the question?
Yeah.
Yes. Then what about power 4?
Mm.
No, right? Right? Okay, sorry, a bit of a small reminder on the notation. When you put double tilde approximately, you no longer need to put plus dot dot. However, if you put equal sign over here, then you have to put the plus dot dot. Because Maclaurin series expansion has infinite number of terms. It goes on forever. It does not stop. We can only write down a few finite terms relevant to the question. In this case, up to x cubed. Oh, then let's just clean up a bit. 1 minus 2x plus this one, -2 squared and x squared. So clean this up, I'll get positive 4. Wait, positive 4 over 2 factorial. 2 factorial is really 2, so 4 divided by 2 is just a 2. Okay, I'm skipping steps. Is that okay?
Mm-hmm.
Can clean up, you get 2x squared. And the next guy is -2 bracket power 3 x power 3 over 3 factorial, which is 6. So you can type in a calculator -2 cubed then to the power divided by 6. I end up with a -4 over 3. You can even type the 3 factorial in if you're lazy. Don't want to do mental sums. Then you get x cubed. Okay? Good. That's fx. Now let's continue to gx. This time you got ln of 2 plus x. Now let's take a look at the formula list. What we have is actually what? We have ln of 1 plus x, right? Available here. However, look, this is 1 plus. Yeah, I didn't write this down in the notes, but this must be 1. Okay, so we have to use logarithm rules to help us to manipulate it until we get a 1 plus. Is that clear? Not clear, then let's see the example, it will be clearer. So what I mean is ln of 1 plus 2x, we cannot work with this. We cannot work with this. We only accept credit card or something. We don't accept GrabPay. So what do? You must convert into the correct currency. Actually, that's a bit impossible. More like you accept GrabPay, but you don't accept credit card. So you have to transfer money to top up your wallet first. Do some conversion before you can use their system, their payment system. Similarly, in Maclaurin series expansion, we can only use whatever is provided to us in the standard series expansion, which is a 1 plus x. Here you have a 2 plus x. So what do? If you try ln of 1 plus x, that's no go. Cannot. Why? Because this expression has 2 terms inside. It will make your expansion very, very painful. You see, what you're gonna do if you do this is you're gonna replace the x with 1 plus x, which means that if you look carefully at your expansion, all these x squared, x cubed are gonna be a binomial. Then you have to use binomial theorem to expand. Very painful, right? You see that? It's very painful. I think if I'm not wrong, it does work. It does work. It's just that it's very inefficient. Okay, so here's a better way. Multiply or factorize. Ln of 2 factor out 1 plus x over 2. Agree?
Yeah.
Agree? Hey, just nice. I have a 1. Nice. Very, very good. Then what do you have? There's multiplication here. What happens when you have ln of multiplication? Split into a sum. Ln 2 plus ln of 1 plus x over 2. Okay so far? Yes. Then we're just gonna pretend this one is for exam trick. Technically, if you imagine in the ancient past when the calculators were not available, ln2 cannot be calculated, right? And the purpose of doing Maclaurin series expansion is really just to get an approximate value of this guy up to a few terms in x, and then you substitute x with a certain value, let's say 0.1, and you can substitute on the right hand side, then you get an approximation. But here I'm doing a clever trick to make use of calculators, which is a little bit backwards, going against the purpose of Maclaurin series expansion. But for the sake of time, we will do this trick. We will assume that we already have the value of ln2. and we have access to a calculator to help give us the decimal value. Okay?
Yeah.
If you are trying to estimate. Anyways, with ln 2, let's leave it alone. Plus ln of 1 plus x over 2. This one we can start to use the formula. Why? Because we have a 1 and then we have our x replaced with x over 2. Okay? So we're going to do that. Replace the x with x over 2. Let's reference the formula. Let me take a screenshot so it's easier for me to copy the things. Copy, go back, paste it, sub in. Oops. So what we have? X, but in this case it's x over 2. Subtract away, bracket, power 2 over 2. In this case it's x over 2 in between the brackets. Plus
x over 2 to the power 3 divided by 3.
Yeah. And then minus, okay, do you need the power 4 sum? Let's just expand it so you can see it first. Do you need this guy?
No.
No, you get the pattern, even though it's not in the formula. Now you increase 3 to 4, but change the sign from plus to minus, alternating pattern. Can Okay, good. But this one not relevant, so you ignore it. And then you plus dot. Okay? Because it goes on forever. Very good. Now we clean up. So ln 2 plus half x minus x squared over 2 squared divided by 2. So that's 1 over 8x squared. Right? Then some power 3 is 8. 8 times 3, 24. 1 over 24 x power 3. Correct? Can Okay, good. Now we got fx, we got gx. Let me just delete this so I can have more space. Then we just write down e power negative 2x times ln 2 plus x will be approximately 1 minus the answer from fx. I duplicate it, put it here, bracket. And the answer from ln of 2 plus x, the approximated up to the x cubed terms, the approximation up to the x cubed term, you write it down, and then you just put equal sign already. Then now we have to expand the x cubed term, right? Up to. They say up to, not only. They say up to and including. So that means we have to really expand everything. Let's just do it. So constant terms, what is it? 1 times 1, 2. You get ln 2. Linear terms, what is it? Constant times. Okay, I like to write it this way. Maybe it will help. This is x power 0. I use a pink pen. Power 0, x power 1, x power 2, x power 3. X power 0, 1, 2, 3. Let's write it down like this. X power 0, 1, 2, 3. And then I duplicate it. Then I'll use this as a table to help me. Now I want linear term. How do I get linear terms? Isn't it just x0 times x power 1? Then x power 1 times x power 0. So that means that you can take 1 multiplied by half x, and then minus 2x multiplied by let me see, ln 2. Make sense? To get our power x terms?
Yeah.
Yes, then you just have to write down, I like to write it like this, plus x, open bracket, then you just multiply the coefficients. This one times that one, 1 times half. Next one, negative, oops, sorry, I want to highlight them. Negative 2x multiplied by ln 2. So negative 2 ln 2. Then write down minus 2 times ln 2. Just don't even write the plus sign, the times sign. Okay, that's x. Then plus, no space, I write at the bottom, plus x squared bracket. Let's see, how do you get x squared? X squared times constant, right? X squared times a constant, x times x, and then x constant times x squared. Can you see that? The 3 pairs? Definitely not x power 3, right? Can you see that? Yes, no? Yes, so that's really just 1 times negative 1 over 8. You get an x squared. So 1 times negative 1 over 8. Plus the next one, this pair. Negative 2 times 1/2. So minus 2 times 1/2. Next, we have 2x squared times the constant. So 2 times ln 2. Positive. 2 ln 2. Okay. Next, we go on to x cubed. How do you get x cubed? Let's look at this table again. X cubed times constant gives me x cubed. X squared times x gives me x cubed. X times x squared gives me x cubed. Constant times x cubed gives me x cubed. So you have to have 4 pairs. Is it clear? The 4 pairs are here, 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 and here. Can you see that?
Yeah.
Yes, okay, we go for the first pair. 1 times 1 over 24. This part, is it okay? Are you starting to recall your binomial theorem already? This type of
A
question?
bit.
A bit, Then negative 2x times negative 1 over 8x squared. So plus negative 2 times negative 1 over 8. X times x squared gives you x cubed. I already factored out the x cubed. Plus, next one, 2x squared times x, so 2 times half. Plus, the next one is negative 4x cubed times ln 2, so negative 4 third ln 2. I'll just, never mind, just put bracket. So you see, when you put plus sign already, then just put a pair of brackets, then you will be safe. Then don't have to worry about, oh, I forgot to put a pair of, the sign is wrong, then I scribble away, I put a minus sign, very messy. I'll just put a pair of brackets, just put a bracket. Anyways, you can use a calculator to help you to compute all this. Okay, maybe I put square bracket, looks nicer. After a round bracket inside, then put square bracket outside, is it? The standard? Yes. Okay, then puzzle dot. And that's your answer already. The rest is just simplifying. I'm not gonna do it. Can? This one just simplify, simplify, simplify. That's all. Maclaurin series. Easy? Yes, easy. Good. Next, we move on. State the range of values of x for which the expansion is valid. So let's see. E power negative 2x, right? We use the formula here. There's a range of valid x. They tell you it's all x. So even if you replace with 2x, it's still all x. Is that okay?
Okay.
Okay, good. So if you want to really represent it with a number line, it means that e power x, they satisfy all the numbers here. This is a number line. 0 here, 1 here, negative 1 here. It satisfies all our numbers. Then next one, we have, what is it? Ln 1 plus x, we use this formula, right? They tell us that x must be in between -1 to +1. Yes? Let's write that down. Ln 1 plus x. The domain of validity is -1 less than x less than equal to 1. But here, we didn't use ln 1 plus x directly. We did a clever trick. We factor out the 2 first, then we use x over 2 as our variable. Correct? Okay, we're using ln 1 plus x over 2, which means that if I zoom out, this variable here and that variable there, we're going to replace it with ln of 1 plus, what is the variable? Not x, but x over 2. Clear? Yes? Cannot. Following?
Yep.
That means that our domain of validity will be -1 less than something less than equals to 1. But what's in between? Is it x in this inequality? No, it should be. X becomes x. X over 2, then over here must also be
X over 2.
Very good. Then you multiply throughout by 2, you get -2 less than x less than equal to 2. Then you have to update your number line. So maybe I don't need the zeros and ones. I'll just put a -2 here, +2 here, empty circle for -2 all the way to solid circle for 2. Then you find the overlapping region. Where is it? The condition on e power 2x is all, the domain for the e power 2x is all x values. The domain for this ln 1 plus x over 2 expansion is -2 to +2. Exclude -2, include +2. Then where's the overlap? Can you shade in for me? Shade in, shade in. Cannot draw? Where? Okay, I see it. Do you know where it is? The overlap?
Where?
I don't know. Okay, so it's over here, you see. Can you see the overlap?
Oh.
That means that It's just the domain of the ln 1 plus x over 2. Just so happens, okay? If you have in the future, I give you another question that is ln of 1 plus x, and then a sine of, I don't know, what could I give you? Sine of x. Then you try to find expansion, Maclaurin series expansion. This guy will give you a restriction on the x, which is -1 less than x less than or equal to 1. That guy will give you a restriction on, let me see, what was it? Sine x is all x. Oh, sorry, it works on all x. Not very true if you only expand up to a few terms. Let's see what's a better example. 1 plus x power n. If I give you another 1 plus x power n, you just have to use the formula. But this one, the restriction is modulus x less than 1. In other words, -1 less than x less than 1. Right? Then in this case, maybe let's just play around. I don't use x instead. I use x over 4. And this will become x over 4, x over 4. Okay? And this, if I multiply throughout by 4, I get -4 less than x less than 4. Do you see that? The two range of values of x are allowed. Yeah. So without expanding, you can find out this. This is another example. Maybe I should start a new page. Sorry. Cut. Then in that case, you also have to draw number line. The first domain is from -1 to +1. So empty circle here, solid circle there. The next domain is -4 to +4. Oh yeah, no space. Okay. -4 to +4. Then that means you'll have empty circle here, empty circle there. Where's the overlap? Where is the overlap? Imagine you have a stick here and another stick here. Where's the overlapping part? Correct. Good. That means that you have, I like to draw it like this. And I draw in the middle here on the overlapping part. Right, then therefore the restriction must be -1. You don't include, right? Because this one, you see, for the -4 to +4, you have solid circles here. Many solid circles here. You're including those points. What's the overlap between include and don't include? Must be don't include. So that means you don't include the -1. And over here, at +1, there's a solid circle here as well. So what's the overlap between include and include? Must be include. This is our logic, and or logic. Okay. This is like, think of this as what are the type of numbers that you like. Then for the first interval, they say, I like all numbers that is bigger than -4 and strictly less than 4. So that also includes this value here, -1. I like -1. Then for this other interval, when there's an empty circle, they're saying, I like all numbers in between -1 and +1, but I don't like -1, I like +1. So here you say don't like. Here it says like, do like. Then what's the overlap? What's a common thing that they both like? It must be not -1. The guy who is more niao, who doesn't like something, you have to satisfy the condition. Or you can think of it like you're going out to eat with your friends, then some people don't like to eat fish. Then another friend don't like to eat vegetable. Then you must eat a common food in a restaurant. So that means that you go for food that has no fish and no vegetable. Does it make sense?
Yeah.
Or more like maybe this guy, he likes veggie. This guy, he don't like veggie. So you satisfy the stricter guy, which means you don't include veggie. Make sense? Can yeah, satisfy the stricter condition, basically. Satisfy the stricter condition. Maybe I read this one. Satisfy the stricter condition. Okay, so that is your final answer. This is known as the domain of validity. Okay, for the previous question, domain of validity is just, I'll just call it domain, will be -2 less than x less than 2, inclusive of 2. Okay? Because you substitute x over 2. Okay, very good. Let's go on. Stop me if you got questions. Question What is it? Using standard series. I think this one you can try as homework. Oh, then for question 4, this one. Okay. Let's try this a bit more long-winded question. Let's go. So given that y equals to tangent x, show that d2y dx squared equals to 2y times dy dx. So y equals to tangent x, you must remember the derivative is secant squared. Yeah? d2y dx squared, this time you have to differentiate secant squared. Power rule tells you bring down the old power. -1, get a new power, so it's just secant x, then differentiate secant x. So how do you differentiate secant x? Secant x is really just 1 over cosine x, which is cos x power -1. So that means if you differentiate secant, it's the same as differentiating the cos x power -1. Bring down the old power, -1 to get the new power, then you times derivative of cosine x. I'm running out of space. Let me just bring it over here. Times the derivative of cosine x, which is negative sine x. Simplify, you get negative is positive. So +1 over, sine x positive divided by cosine x squared. Right? Simplify this, you actually end up with sine x on top, cosine x below, times 1 over cosine x. What's sine over cosine? Tangent. What's 1 over cosine? Secant. So this is tangent secant. Yes?
Yeah.
Good. So now, what did they say? Show that it is 2y times dy dx. What you need to realize is that, here got secant and secant. Isn't it just 2 times of tangent x times secant square x? But wait, what's tangent x? Blue color, y is tangent x, so that becomes 2y. And secant square? Secant square is... secant square is... Can you see pink color? Secant square is?
Yeah.
Secant square is... Okay, wait, actually, to make it look nice, let me try and make the color coding the same. Everything black color. Then I change my highlighting to blue color. Then you can see very clearly. Replace the blue with y, replace the pink with dy dx, and then you get your answer. Can? Okay, maybe I'll use pink color, fine. Then you get the idea. So that's how you show this kind of things. You must compare with the previous guys that you just found. Hence, find the Maclaurin series for y up to and including the term in x cubed. So this one is tangent x, but we found a trick, which is that y equals to tangent x. dy by dx, the first derivative, this is f1, is secant square x, and d2y by dx square happens to be something in terms of y, so 2y dy dx. Now we find Maclaurin series expansion up to which term? Let's see. X cubed, right? X cubed means you need up to which derivative? X cubed is power 3. So which derivative? This one currently power 2 only. So you need to... What? Tell me. What do you need to do?
What do you mean?
This is the second derivative, right? f2 of x. This will help to contribute to the coefficient a2 of the x power 2. Now they ask for up to x cubed. So what do you need? Find
third
the third
derivative.
derivative. Exactly, yeah. So the derivative notation is the d something notation is d cubed y by dx cubed. Okay, then how do you differentiate this? Let's see. You must remember your implicit differentiation, okay? There's a product going on. So you keep one, differentiate the other, differentiate y, differentiate dy dx, you get d2y dx square. Okay? And plus product rule, right? Keep the other, which is keep dy dx. Then you differentiate 2y, what do you get? Differentiate 2y.
You get
Must remember the cat. Cat must have a
dy dx tail.
correct. Very good. Finally remember. Okay, I draw for you the monster cat. This one looks so weird. Okay, a monster dy dx tail. Okay, must remember. So that means that you end up with this. Yeah, good. That's it. Don't need to simplify. Don't simplify. Oh, by the way, here when you have multiplication going on, please don't go and distribute the dy dx inside. This is our times, not our plus. So it becomes 2 times dy dx bracket power 2. Not to be confused with second derivative, okay? Different ideas. Is it clear? Yes? Okay, good. Now, I clean up. I need more space. I don't draw the cat. Very messy. Don't need so many details. Very, very messy. I'll just clean up. I'm copying everything, but just the relevant expression. Then I draw a line, so it's a bit clearer. Oh, less is more. Blank space, very important. Then you now have y of bracket 0. You've never seen this notation, right? Now you see it. Draw a line x equals 0 as well. Never seen before, now you have seen it. Dx squared, sub in x equals 0. d3y dx cubed, sub in x equals 0. Let's see what this is equal to. Well, same procedure, just different notation. Sub in 0, tangent 0 is 0. Secant square 0 is, secant square is 1 over cosine square 0. You replace with 0, what do you get? Cosine 0 is 1. So cosine square 0 is 1 square. 1 over 1 square is 1. Okay. Then here there's a problem. Oh no, how come we got y here and dy dx? How do I sub? So you need to realize that what you're doing is replacing x equals 0, which means here it becomes y of 0. Y bracket 0 means what? Means you take the expression for y, which is tangent x, replacing the x with 0. So you can just recycle the value of y you found before. So this is 2 times y, which is 0, and times dy dx, which is 1. Does it make sense? Yes, no?
Yeah.
Yeah, then this is equal to 0. Then the next one, 2y. Again, 2y is 2 times of the value of y when x equals 0, which is 0. And then multiply by second derivative, which we found out is 0, plus 2 times of dy dx power 2. What's dy dx? It's 1. Right? dy dx is here. I don't draw the arrow, very messy. I hope you get the pattern. Can or not? I use highlight.
Yeah.
I think y here, and d2y dx square was d2y dx square is 0 here, so you replace with 0, and then 2 times dy dx. dy dx is brown color, so I put a brown here. Can color coding okay Then you finally get a 2. Okay, that's good. Now we use formula. So fx, which is the tangent x, will now be expanded as 0 plus 1 times x power 1 plus 0 times x power 2 plus 2 times x power 3. Can you see that? Sorry, not enough. Must divide by 1 factorial. I forgot. Divide by 2 factorial. Divide by 3 factorial. Is that okay? If you want, you can introduce another column, which will be your A0, which is 0 divided by 0 factorial. Your A1, which is whatever coefficient you had before, divided by 1 factorial. A2, which is the 0, the orange color 0, divided by 2 factorial. And A3, which is the 2. What 2? This 2. Oh, this 2. Divide by 3 factorial. All right, then you sub in into the formula. Just power 1, power 2, power 3. Okay? That's the Maclaurin series expansion. The rest is just simplifying. I'm not going to do it. You can do it yourself. Next one. By using the standard series expansion for ln 1 plus x and Maclaurin series for y, find the series expansion of ln 1 plus ln 1 plus tangent x in ascending powers of x up to including term in x cubed. So ln of 1 plus tangent x, what does that mean? It means, we gotta find ln of 1 plus tangent x. I only got 5 minutes left. I need to replace the x with a tangent x, okay? Let's simplify tangent x. Okay, no choice. If not, I cannot solve the rest of the question. This is x plus 2 over 6, which is 1/3 x cubed. Okay, then you have to use the formula for ln. I cannot remember. Then I reference to formula list. Ln 1 plus x, this guy. We'll deal with the domain later. It's over here. We're going to use the formula now. So x, which is now replaced with tangent x, minus away x, which is tangent x, power 2 over 2, plus x, which is tangent x, power 3 over 3, plus ... so on. Here, I actually probably don't need so many. I don't need power 4. Why? Because the question requested for up to x cubed. Okay, up to x cubed. If I go for power 4, Okay, let's see what happens. It should be a minus. Tangent x power 4 over 3. No, over 4. I'm going to replace tangent x with this guy. Will this contribute to x power 3 and lower powers? Yes or no? Definitely no. Can you see why? This one power 1, this one power 3. You try to expand power 4. What's the smallest power? Must be the first term, right? X power 1 to the power 4. Then everything else is going to be higher. So the smallest power will be x power 4. Is that relevant to the question?
No.
Up to x cube. No. Very good. That's the point. So you don't include this. Clear? Okay, only expand up to x cube, so you only expand the relevant expressions. And then finally, you replace tangent x with x plus x cube over 3. 1/3 x cube. Everything. Do it. Divide by 2. And then you need to clean up. Okay, can I just delete? Okay, I'll just put this at the side. Shrink it down. Move on. Clean up. This one, no choice. You have to expand. So we're gonna have a squared plus 2ab, 2x times x cubed over 3. I'm just gonna clean this up a bit. 2/3 x power 4. Is it okay? 2/3 x power 4? Okay, erase. And then plus the b squared, which is x cubed square, you get x power 6. 3 square, you get 9. All divided by 2. Plus this one. Wow. I hope you remember the binomial coefficients. 1, 3, 3, 1. So you expand a plus b bracket power 3, you get a cubed plus 3 times x squared times x cubed over 3 to the power of 1 plus 3 x power 1. See, 3, 2, 1. Okay. And the other guy is power 2 plus x power 0. Just coefficient 1 as well. X cubed over 3 power 3. All divided by 3, correct? Yes. But of course, we are only expanding up to x cubed terms. So if you're faster, please go ahead and skip the terms which are irrelevant. Clearly, this one power 9 already. So we skip. Okay, I use highlighter. Skip. This one 3 times 2, 6 already. Definitely out of the case. 2 times 3. 2 plus 3, you get 5. Definitely not relevant anymore. The only relevant one is x cubed. So if you can see that the terms are irrelevant, don't need to expand. Clear? Same thing over here. You got x power 6, also the one. X power 4, also the one. Just skip. You don't need to write down. Just put a plus ... to help remind me that you skip some of the terms. Can you please help me to put a ... Okay? When you do your homework. Okay, then simplify a bit more. X plus x cubed over 3 minus away 1/2 x squared. And then you plus 1/3 x cubed. And then you just plus ... Very good. Then you just combine. So you have x. I like to write it in increasing orders of the powers. X power 1, x power 2, then 1/3 x cubed plus 1/3 x cubed. That's 2/3 x power 3. Okay? And yeah, good. That's it for this. Expansion, ascending. Okay. Hence, show that the first 3 non-zero terms in the expansion of this guy are 1 minus x plus 2x squared. Huh? What is this? I don't understand. What? Are you telling me to redo fx equals secant squared over 1 plus tangent x? Do the whole thing again? Wow, differentiate, equals 0. Submit the formula? Wow, so long-winded. Cannot. This is a hence question. So you have to be creative and think carefully. What have we expanded previously? Let's see. This is a hence question. So we found out the expansion for tangent x. Let's summarize our findings. This fellow, I'm going to copy it. Oh, my tree looks pretty bad. Okay, so we have this.